Now let's say we're dealing with a variable that's defined implicitly. So if we take the surface yz plus x ln z equals y squared minus 1, then we can't isolate the z variable, but we can still find the partials of z using implicit differentiation. So we'll apply del over del x to both sides, treating y as a constant. So that will give us y del z over del x plus, and now we use the product rule, ln of z plus x del z over del x over z equals 0. And so then solving for del x or del z over del x, we get that this is negative ln of z over y plus x over z. Then for the other partial, we can apply del by del y to both sides. Now treating x as a constant, so this will give z plus y del z by del y plus x over z del z over del y equals 2y. And so now we solve and we get that del z over del y is equal to 2y minus z over, over y plus x over z. Here's a second example. Let's look at cos xy equals sine yz plus 1.3. So that gives this wild-looking curve or surface. And in this case, we can't isolate any of the variables in terms of the others. So let's calculate del x by del y and del z by del y. So we'll take the partial with respect to y and hold z constant first. So that gives del x by del y times y plus x times sine xy, and then a negative in front. So we did the product rule inside. We did the chain rule and then the product rule for the xy. And then this is equal to, now z is a constant, so this will just become z cos yz. And now we solve, so that gives us negative del x over, let's do del x over del y times y plus x equals negative z cos yz over sine xy. So this becomes, we can move the x over, equals negative x minus this, and then divide by y. So this is our expression for del x by del y. Let me box that so it's safe. Okay, now for del z by del y, we'll do the same thing, but now holding x constant. So now we get negative x sine xy equals z plus y del z by del y cos yz. And so solving, we get z plus y del z by del y equals negative x sine xy over cos yz. So then we want to move negative z over and then divide by y. So this is what we get for del z by del y.